Hi, in this video, we'll talk about another popular concept called solid design principles. Solid is an acronym where S stands for single responsibility principle, O stands for open closed principle, L stands for Liskov substitution principle, I stands for interface segregation principle, and D stands for dependency inversion principle. In many interviews, you'll be asked directly or one of the principles to whether you understand these solid principles or not. Even if they are not asked, it's very important for all the software developers to understand these principles so that they can write a code which is like really easy to maintain, it's readable and extensible. So that's the whole point of these principles. And I'll explain these in very simple terms by taking examples from our day-to-day lives and connect how software engineering is closely related to our day-to-day lives. Okay, so the principles that is applicable for other aspects of our lives, the same principles are used in software engineering too. Okay, so let me go through them one by one and we'll understand each of the principles in very simple terms using examples from our daily lives. Let's go ahead. S O L I D, solid design principles. So S stands for single responsibility principle. So what does single responsibility principle mean? So to understand in simple terms, let's take an example. Say we have two subjects, okay, science and English, okay, and each of the subjects have their own core theme. Why are the subjects there for? Okay, so science has its own domain and English has its own domain, and each one should talk only about that specific thing. Okay, to illustrate it further, so science should only deal with all the matter or the material world that we have in that we see around us, and English is it deals with literature and poetry and so on. So if so when I talk about single responsibility principle, this means that we cannot have poetry in a science book. So if you see that if you write a poem in a science book, so that's violating the single responsibility principle, because science doesn't deal with poetry. There's another specific field which deals with that. So that's what is the single responsibility principle. One domain, and in software terms, one class or one method is responsible for only one and only one thing. Okay, so if I write it here, so you can have a class science and it will have all the material world, and whereas similarly if we have class English, it will deal with, say, literature, poetry, and so on. So understand, right? This thing should not go there and this should not come here. It doesn't make sense. And it so that's what is the whole purpose of writing our classes in such a way, so that the thing which needs to be there should be at a particular place. Okay, and all of the things which are closely related should be in one topic, one class, and that should be the only responsibility of that class. You should not have things which don't make sense there. That's the single responsibility principle. One and only one thing. Science means science, English means English. Clear segregation. Okay, going ahead, we'll continue this example. Oh, this stands for open closed principle. Open for extension but closed for modification. What does this mean? Okay, open for extension. So if we continue this example, right, so again continuing with this example, so with respect to science, we cannot science only, we talked about, right, so science should only deal with the material world. And you can have subjects like physics, which deals with the physical world, chemistry, and bio. Similarly, English has its own domain. Okay. Now, if you see here, if we modify science and if we say from tomorrow we will teach poetry also in science, so that will not be accepted. That doesn't make sense, right? So that's the modification of the core behavior. So we should have our classes in such a way that even if somebody wants to change the behavior of that class or the reason for its existence, that person should not be able to. It will be a very absurd. Okay. So that's that's closed for modification. And what do you mean by open for extension? So open for extension means, say if there are new theories which have been discovered or observed by scientists, so this field of science should have the scope for adding new theories. It's open. It will go on till infinite time, till human beings are here. Science will keep on developing and new theories will be added every now and then to science. So this shows that how it's open for extension. Similarly, in software world, so the new things which will be added in a software, right, those will be features. So if we have a class science, so it will have theory 1, theory 2, and theory 3. Say if we have 3 theories for today. Okay. And in future, so this is like till date. And scientists are working every day and night. And if they want, and if they discover something, so it's very well possible to add another theory in any of the field of sciences. And we can easily extend this class science to add this new theory. I hope you get the point. So that's our open close principle. Now moving ahead. Next is L. Liskov substitution principle. So those two were like pretty straightforward and most people understand that. And the complexity starts beginning from here. So what's Liskov? So Liskov is a name of a scientist who proposed this principle, and on that person's name this principle stands. What does this principle talk about? Okay, so I'll give you another example here just to understand it. Let's consider a class or a category. So we will go to classes later. So same thing will be we can talk it as a class because classes are framework. That's the object oriented way of talking about things. Okay, so let's consider an example where, say, if we want to define a framework or a category. Okay, so if we talk about animals, right, and we want to define a category of these living beings which are animals, so what common things or behaviors do you see that occur across all animals? Okay, so only those things can be clubbed together to call an entity animal, to make it simpler for you, right? So if we say that an animal, how do you want to define that? That's the definition. If you say that, how do you define an animal? So it comes to that. So if we say that an animal eats, okay, so yeah, an animal eats, and that will be applicable to all the animals that we see around. Even if it's a unicellular organism, it will have to eat or consume something in some way. Even it's a bird or a fish or anything which moves on land, reptiles, anything, chordata, non-chordata, all classes of animals they eat. So that will be applicable to all the animals. So we can easily say that all the animals we can say that all the animals eat. Similarly, we can also say that they breathe. Yes, all the animals take in O2 and give out CO2, right? It's applicable to all the animals. So this, but now if we say an animal walks, right, is it applicable to all the animals? If we say an animal, okay, say if it's a cat, okay, it walks. If it's a dog, okay, even a dog walks. But what about if we say a fish? A fish doesn't walk, right? So we cannot make a statement or define that an animal has to walk. birds fly, they can walk too. But with respect to fish, right, we cannot impose, or we cannot define that an animal should walk. There are unicellular, very small organisms which don't even have legs, or forget about that. So we'll keep it at a macro level where we can see. So fish, if we say that fish needs to walk, that's a wrong statement. Fish don't walk, right? So what do we do? So we should not define our abstraction or the parent to be it, to have such behaviors, so that when we inherit from that, so that when we go towards specialization, if we talk about animals, so cats, dogs, and fishes are specialization of animals, right? We are being specific about that. So when we talk about specifics, so the same thing what we can talk about animals should also be applicable for the specific things that we talk about, right? So that's Liskov substitution principle. So the substitution means we can take the base entity, the general thing, and we can implement or talk the same behavior for the specific things also. So I can say a cat eats, a dog eats, and a fish eats, and it will be a valid statement. I should not have such behaviors in my parent or a general abstraction which will not be applicable to a specific use case. So we should have only those behaviors in our abstraction which will be applicable to all its specific use cases. So I hope you get that. Continuing with the next example. So next example is that's interface segregation principle. Okay, again, for this I'll come up with another example. So let's think about a company. Okay, so a company needs to interface with the world, right? If there's a big company, when you will be aware of companies, right? So there are different departments in the company. Say there's an engineering department, there's a marketing department, there's a sales department, right? And each of the departments will be interacting or interfacing with the external world, right? So now as a client, okay, if I want to talk to the company, right, how will I, so if I have a specific purpose, so if I want to talk about, I need to purchase something from the company, so I'll go and talk to the sales team, right? And if I have an engineering clarification, or if I want to understand how their product works internally, or what's the engineering design of that product what they are selling, right, then I'll go and talk to the engineering team, right? So what if we make only one interface where all the, so we have only one interface to the company, where when a client comes and wants to interact with the company, right, it's forced to interact with, if it wants to come for sales inquiry, and I'll force it to talk to marketing and engineering team too, that won't be a good user or a client experience, right? The client should not be forced to interface with the things which it doesn't want to. So we should have lean interfaces, or the interfaces should only talk about or deal with the specific thing that it needs to do, and do only one thing. It's also again related to the single responsibility principle, should do only one thing. So that's interface segregation. We are segregating, as in companies we segregate, like engineering will have a separate interface, marketing will have a separate interface, sales will have a different separate interface. So that's segregation we have in the company. Similarly, when we write code for our service, the company is providing some service, right? So when we're providing a service, the interfaces which we provide, the client code should not be forced to interact or write methods which it's not using. It's forcefully writing it, right? So if I write it in like class, so if I have an interface company, right, company, and if it's an interface, I cannot company, I should not have like contact sales, contact engineering, and plus contact marketing. This is bad. When a client comes, if he has to talk to only sales, he will have to forcefully talk to engineering and marketing people too. That's definitely your clients are not going to stay. Okay, they'll run away. Nobody wants this hassle. So what do we do instead is we break this one big interface into three separate segregated interfaces. One will be iSales interface. Okay, and sorry, and it will have only the contact sales method, and then we will have, sorry, I engineering, and then contact engineering, and so on. I hope you got the point. So this is your interface segregation principle. Now continuing, the last one is T, that's dependency inversion principle. Again, let's take another example to understand this better. So for this, I'll take an example of a mobile phone. Say we use mobile phones, right? So mostly there are two kinds of phones that they are in market which are famous. One is the Android phone, and another is the Apple phone. So a phone is composed of many components, and one of the components is the charging port. So if you talk about Apple, right, so it has a specific charging port where it's only Apple charges come and fit, right? So a specific kind of charger from a specific company, a specific kind of charger only fits in there from a specific company. Okay, it's not open to all the companies. All companies don't make it. So only people who can make that specific kind of charging port and the charger will only be able to charge an Apple phone. So that's a closed design or a concrete dependency. An Apple phone depends on a concrete charging port. Okay, so there are two parts. There's a charging port which is there in the phone, and there is a charger which comes from another company. Apple makes, and there are some cheaper versions of that too, but its specifications are defined by Apple. So it's a concrete dependency on a specific constituent of the bigger product. So that's not a good design. It's not open. Okay, so that's why we say that Apple is a closed community or closed ecosystem. It's not open to all the interfaces. But a better design would be like the Android world, where we have everyone, most of the phones that, and even the countries are imposing that. Going ahead, all the phones should have USB-C type ports, right? So what happens with that? So when we talk about USB-C charging ports, right? So now, when with the charging port that Apple designs, or which it has, right, it's designed by Apple and it controls all the things. But when we talk about USB-C, right, there's a separate standard for that, and that separate standard defines what will be the standards for creating both the port and the charger, right? So now, instead of depending on a concrete implementation, so today you have a USB-C, tomorrow there'll be USB-D, and so on and so forth, but not one single company will define that this should be the size or the structure of that charging port. Whatever the standard defines, everybody aligns to that. And the companies that make the charger and the companies which are making the phone and the ports, they need not be of the same company, or they need not know. So they will both refer to a third thing, which will be the third the standards, the IEEE, or someone who is giving this standards or specifications, and both the parties needs to align or be compliant with those standards so that they can interoperate. So you see here, so instead of depending on a concrete port, those standards have been standardized, and a third party, or that's an interface, maintains that. So now the third party standards, or the standards that is there for the USB-C or USB-D or E, what will be coming in the future, that is taken care by a third party, and both the client and the concrete product, both of them, they will depend on that, and they will design their class in such a way so that they can use that third party thing. So that's not dependency inversion. So what it says is both the dependent, the sorry, a class should not be dependent on concrete implementations. Instead, it should depend on abstractions. And now the composing of the, say if it's a phone, right, and it has a charging port. So this will be now a type of interface charging port. It will not depend on a concrete charging port. It will be an interface of charging port. And similarly, the charger which needs to go and fit in there, right? It will depend on that interface of charging port. And this, so instead of earlier, for the charge to come in, right, we would have to create a charging port object and assign it here instead of having this interface. Okay, so that was a concrete, so we'll have a concrete member class here, but now it will depend on an interface of charging port, and that charging port standard will be defined by a third party or a standard body, standard governing body, standard body. And both the charging and the charger parties needs to be compliant of those standards. So this is how we invert the dependency. Instead of depending on concrete implementations, we both the base class and the class which is composed of the both of them are depending now on an abstraction or interface. Okay, and the dependency is inverted now. So the companies those we are making, which are making this charging ports, right? So anybody can make this charging port now, and they will be compliant with this. So now standing this iCharging port interface, iCharging port interface will be defined by this, and the clients which need to make that, they will inherit from this iCharging port, and we can have like different companies can make. So we can have Samsung and OnePlus. Everyone can use this, and they can make their specific versions of charging. They can be different in their look and feel and design, but they will be compliant to this iCharging port. So I hope this was helpful. So in short, I'll just reiterate all the principles again so that we conclude it. S stands for single responsibility principle. O stands for open closed principle, where O is open for extension, C is closed for modification. L stands for Liskov substitution principle. I stands for interface segregation principle, and D stands for dependency inversion principle. Thank you.